This is the second half of the lecture for section 1.1. We're still working with categorical variables, but we're going to look at ways in which we might talk about how two categorical variables interact. This is a really important thing for us as humans to figure out because we want to know whether things are related to each other, associated with each other. We want to see whether things these things make differences. Probably the most um, important version of this is like, do you think smoking is related to lung cancer? If you do, then the data should be able to show that relationship. And well, whether or not you smoke is a categorical variable. Whether or not you have cancer is a categorical variable. Well, the data that we'll look at is a little bit more optimistic than all that. Let's get to it. The major tool for investigating the relationship between two categorical variables is called a two-way table. Uh, a two-way table, um, a two-way table has what attributes? Well, it organizes, and again, there's that theme again. What do we do as data scientists? We organize. It organizes data from a single data set, which means there's a collection of individuals looking at two different categorical variables. Okay? So I want you to imagine that we have such a data set. Well, here's one. Here's a survey of 4,826 randomly selected young adults from 19 to 25. And they were asked the question, what do you think are the chances that you will have a much more than middle class income at the age of 30? The table shows responses omitting people who refused to respond or people who said they're already rich. Okay, so let's look at the idea of this two-way table. There needs to be two different categorical variables. Here's a categorical variable, gender. Either you're male or female, at least in this survey. Here's a categorical variable, opinion. What is your opinion about your chances of getting rich? Two different categorical variables coming from a single data set, right? Because this is a two-way table, it describes two categorical variables. And again, we call those variables, in this case, gender and opinion about getting rich. Opinion is, by the way, called the row variable. And we call it a row variable because each row in the table describes the different opinions. Now, this set of categories have a natural progression from most pessimistic to most optimistic. And because it has that progression, they put them in that order. Gender is referred to as, you may have guessed it, the column variable. Okay? And entries under the count of individuals, um, entries in the table are the counts of individual in each of those. So we can say, hey, there were 96 females who thought there were almost no chance of getting rich. How many adults were surveyed? That number is found here, which is sometimes called the table total. So 4,826 were surveyed. How can we best grasp the information from the two-way table? Well, what we're going to do is we're going to look at distributions. Now, remember that earlier in the chapter, we described a distribution as the values taken on by a variable and how often it takes on those values. Well, when we have a two-way table, we have two different kinds of distributions. The first one that we're going to talk about is called the marginal distribution. And the marginal distribution is the distribution of either the row variable or the column variable. Okay. Why do we call it the marginal distribution? Because these values are found on the margins, on the edge of the data table. All right? Really what we're saying is, hey, if I look at only the data on the margins, here's that data. And know what all this data is? This is data about opinion. There's really no information about gender there. What about these numbers on the margin? Oh, these numbers are about gender, but there's no data about opinion in those two numbers. So we think of the marginal distribution as being the distribution of only one of the two variables that are in the two-way table. All right. Now, a little note here. Sometimes the tables include counts, but we want to understand that looking at percentages is often an easier way to digest the data. We have an easier time of thinking about 15% of a data set being something as compared to 1,015 people had that opinion. But is that 1,015 people have a thousand out of 5,000, 10,000, 100 million? Counts are harder to digest. So we often try to change these into ideas of percentages. Let's examine looking at marginal distributions. Here we have that data about uh, chances of getting rich. We're going to look at the marginal distribution of those opinions. So we are only going to be looking at this portion of the data. We're going to ignore temporarily the gender data and just say what about these opinions? So based on this two-way data and based only on this one column, we can say that 194 out of the 4,826 respondents felt that they had almost no chance of getting rich. Um, let's keep on going down that line. 412 out of 4,826. 1,416 out of 4,826. Under good chance, 1,421 out of 4,826. And 4,121 out of, oh, not 4,121, 1,083 out of 4,826. Now, again, hard to digest these numbers written the way they are. So let's convert these into, um, into percentages. So I'm going to switch over to my calculator. I want the handheld only. I want it on top. Let's pull this over here so we can see it really well. All right. I'm going to start a new document, add a calculator page, and I'll type in 194 divided by 4,826. When I do that, it just gives me a different fraction. But if I do the same fraction, the same calculation, hitting the control button before I hit the enter, I get that number, which is about 4.0%. Let's do that one more time. 712 divided by 4,826. Hit control and then hit enter, and I get 14.7%. Now, if I do 1,416 divided by 4826. And if I just put a decimal point at the end of that number, it will also give me the decimal version of that calculation, 29.3%. And I think you understand how to use the calculator from here. So I'll just write down the other two values. 22.4% is the last of those five numbers in the marginal distribution. Our largest number is about 30%. So if we go up by 5, 10, 15, 20, 25, 30, looks like that'll be good. So let's call this the 10% mark, call this the 20% mark, call this the 30% mark. I can go, I think over by 1, 2, 3, 4 wide. So we'll call this the no chance in terms of their opinion. And that represents about 4%. So it's about there. So I'll draw in our little box there. All right. My next box represents some chance. And of course, we're making each of these boxes, each of these bars the same width. That's about 14%. So I'll go up to about the 14% line. It's about there. All right. The next one, 3, 4. This is the 50-50 chance. And this is the one that's about 29%. So about there. The next one is the good chance. And it's also about 29%. All right. And then lastly, this is the almost certain opinion. And this is the one that's about 22%. There's 20, so 22 is about there. There we go. All right. So we've got this great display. Let's make sure we have context. Who were the people being interviewed? This was young adults, and this is their opinions on getting rich. All right. That should be good. And remember, this is all part of this idea of data analysis. What do we have here? We organized. What do we have here? We displayed. Okay. And then what's being asked us to do? Describe what we see. Now, what do we see? What I see is that I think that young people are generally optimistic about getting rich. Now, that's a statement. What I really want to do is I want to link that statement to what I see in the graph. the the three most popular opinions are 50 chance, and that's at 29.3%. The comment there. Good chance, and that's at 29.4%. And almost certain at 22.4%. Okay. Now, this thing that I did here, and that was again taking the ideas, taking the summary that I said, and then saying, this is why I think this. This has a special name. This is called linkage. Okay. And good answers like this have linkage. Okay. Um, we might even say that um, as seen in the bar chart that says where we saw that, all right? But it links our opinion to the the conclusions that we're making. Okay? All right. Let's take a look at part C. It says use the two-way table to calculate the marginal distribution in percents of gender. So now we're changing which portion of the two-way table we're looking at. That's the margin that has the information about gender. So we might say, okay, females make up 2367 out of the 4826 in the survey. And again, we want a percentage version of that. I put that in the calculator ahead of time, so you don't have to see me entering that in. It's about 49%. And that the males make up 2459 of the respondents. And as you would guess, that means that makes up 51% of that data set. And there's that marginal distribution. I said there's two different distributions. The other distribution that we look at with two-way tables is called a conditional distribution. You say, well, what's a conditional distribution? Well, a conditional distribution of a variable describes the values of that variable among individuals who have a specific value of the other variable. There are separate distributions each value of the other variable. Okay, that's a mouthful. Let's just digest that. Okay, so in the previous example, we had opinion and gender. You could have a conditional distribution of opinion amongst those with the specific value female for the gender variable. You could have a conditional distribution of opinion amongst those that have the specific value male. Okay? Imagine another two-way study. Do you have curly or straight hair? That's one um, variable in this. What color do you have? That's another variable. Okay. The conditional distribution would be among the straight hair people, how many were red? Among the curly head people, how many had red hair? Among the brown haired people, how many had straight? How many had curly? Okay. Keeping one value of the variables constant, where we look at the difference in the distributions amongst the other variables. All right? Or this one. What's your favorite sport? This one's using what's called a side by chart. This is called a segmented bar chart. Okay. So basketball is a favorite sport amongst of about almost 40 kids. And you can see that girls make up about 17 of them, because that goes to about 17 or 18, and the boys make up the rest of them, which looks like to be about 20. Okay, looks like amongst volleyball is more popular amongst boys than it is girls because of the relative sizes of those segment chart. It looks like people with brown hair are more likely to have curly hair than straight hair. People who have blonde hair are more likely to have, um, oh, sorry, I got the brown hair backwards. People with brown hair are more likely to have straight hair than curly. People with blonde hair are more likely to have curly hair than blonde. All right, let's go back to that getting rich data. Let's look at the two conditional distributions of opinion. One amongst the females and the other one amongst the males. So how do we calculate that distribution of opinion amongst the females? Well, what we do is we say we're going to essentially just say only this column exists for right now, only amongst the females. So we're going to say, all right, 96 out of 23, 90 or 67, because that's the only group that we're interested in if we're holding the gender variable uh, constant at female. And also the next one would be 426 out of 2367 and 696 out of 2367 and so forth. 663 out of 2367, and the almost certain is 486 out of 2367. All right. Each of these has a percentage. Again, bring up my calculator and I could say, all right, 96 divided by 2367. I'll put the decimal point on the end, so it gives me a nice a decimal answer. That looks to be about 4.0%. Oh, I'm sorry, 4.1%. Again, I can get that number as well, 426 divided by 2367. If I hit the control key first and then enter, then I get the percentage there as well. That rounds to 18.0%. And because it's not fun watching me just enter numbers in the calculator, I have all these other numbers calculated. 28%, 50 point, 20, 50, 20.5%, right? And then again, that's what was going on with the males. What if we wanted to look only, sorry, among that was among the females. What does it look like if we look among the males? Then we're only looking at this column that I just highlighted in pink. And what are those numbers? 98 out of 2459. I've already calculated that. That's 4%. Those two numbers are pretty similar. Next one is 286 out of 2459. That's 11.6%. 11.6%. Wow, compared to 18. That seems like a pretty big difference. Like maybe the females are less optimistic than the males. Let's keep on going. 720 out of 2459. That's 29.3%. Okay, about the same as the females. 758 out of 2459. That's about 30.8%. And then 597 out of 2459. And that's 24.3%. Okay, so on the most optimistic categories, males' percentages are bigger than females. Okay. Oh, on this one about having some chance, boy, the males' percentage is lower than females. Maybe there's a trend there. Maybe we should look at this graphically. All right. Now, these segmented bar charts are a little bit difficult to make. Okay. We'll start with the almost none category, right? And we're also going to say what we got here. Here are the females, and here are the males. All right. Let's use pink for almost none. And I don't think I can do this in highlighter. Hold on. We're gonna do this with different colors. We'll use black initially, and it's about 4% for both. So I'll draw my line at about 4%. It's about 4%, and then I will shade in that part of the bar. So those are the ones that are, say there's almost none. I'll switch to a red, and I get 18%. Well, 18% plus the additional other 4% is about 22%. So I'm going to make my line at about the 22% line. Okay, it's about to. Okay, okay. I'm sorry, the paper shifted on me. I need to undo that shift. I'm just going to keep on undoing. There we go. So about 22%, which is about here, because again, 4% plus 18% gets me about 22%. But for the males, it's 4 plus 11, 11, so it's about 15%. So I'll put this about at the 15% line. And you can see that that pessimistic character value for that categorical variable is much bigger. Let's switch over to blue. Okay, 22% plus about 30% is about 52%. We'll draw a line about 52%. And this whole area is the 50-50 chance. I forgot to put in that this is the sum chance. All right, let's switch back over to the blue. We were at about 15% plus about 30%. We're about at 45%. Okay. And there we go, filling in that. Switch over to the next category. I guess I'll have green. Yep. Green for good chance. 28%. So I was at 52% for this plus 28. Um, that's about 80. And so there's the good chance. And then I was at 45% plus 30. That gets me to about the 65%. So that line about there. And there's the males. And then you can see why we might not use this very much. Um, Switch to that one. Almost certain is going to be, oops, that's too much. All the rest of it up to 100%. All the rest of it. And now you can see that thick blue category is much bigger for the males than the females. So we now have perhaps a takeaway. Now our book tries to give you a structure for dealing with questions, and they call the structure the four-step process. It basically says, hey, if you're going to do work on some statistics, um, why don't you break this problem down into some steps that are sort of easy to manage, right? For example, in the previous data set, what were we trying to answer? Um, is there a relationship between your gender and your likelihood, your thoughts about getting rich? Okay. Plan. How are we going to go about answering that question? Well, we could say we are going to attack that problem by looking at the conditional distributions of opinion for each of those gender values. Okay. The do step, the third step. What are we going to do in order to answer that question? Well, let's actually do and make those segmented bar charts. Let's make those marginal distributions. And then the last step, and this is the step that the College Board thinks is most important. Well, what did you conclude? Well, here's what I think I conclude. I conclude that males seem to be more optimistic than females about their chances of getting rich. Now, that's a statement. Can I back it up and link it to something that I saw on the four-way table or the two-way table? Why did I say that? Males have higher percentages in the two most optimistic categories. And then maybe I should even mention that would be in um, almost certain. Males were 30.8%, which is greater than the females' 28%. In um, I'm sorry, and for what was the other category? What was the other answer? Good chance and good chance. Um, that was uh, sorry, this was good chance. This one was, oh, So good chance. And then for almost certain, um, we had 24.3%, which was greater than 20.5%. Okay. And again, what is this called? This is called linkage. This is us not just having our opinion, but backing up that opinion with some sort of numerical um, backup. So we learned a lot in this second lecture of 1.1. We learned how to state, plan, do, and conclude, a four-step process for attacking statistical problems. We looked at how we could use two different conditional distributions to find an association between two random variables or two categorical variables. Remember, we had said that this was important to us, like smoking and lung cancer. We looked at how to do marginal distributions. In other words, we got a lot of tools that we came across having to do with categorical variables.